So now we've moved on to chapter 2. So chapter 2 is the quantum mechanical model of the atom. And so here we're going to start kind of getting into the chapter that I say is a little bit more physics mixed with chemistry. So now we're going to get to that kind of hybrid where we're talking about physics and chemistry combined. All right? One of the parts of this chapter of quantum mechanics is the whole idea of Schrodinger's cat. So you may have heard of it. Is the cat in the box? Is he out of the box? Where is he at? And so this is talking about how do we know where an electron is? Exactly. And you can only know where an electron is if an electron is still. But how do we get an electron to be still and figure out where he would normally be at the same time kind of thing? So we won't get into all that detail, but just to kind of give you an idea that if you've heard of Schrodinger's cat or any of those kind of things, that's what we're talking about when we talk about quantum mechanics. Now, the main thing we're going to talk about at the beginning of this chapter is going to be the nature of light. So we're going to talk about light mainly because light is made out of different particles, which is part of chemistry. So let's talk about the nature of light. So the nature of light has two aspects. It has an electronic aspect and a magnetic aspect. So that's why when we talk about light, we talk about it in the sense of an electromagnetic spectrum, because it has two aspects to it. Okay? So the magnetic spectrum is made of electromagnetic radiation, which is composed of an electric field and a magnetic field. So this is our electromagnetic spectrum, and we're going to talk in depth about every section of the spectrum. The first thing we want to talk about is our frequency, okay? So this is the symbol for frequency, this is our units, and we're going to go into more depth about what is frequency, all that. But I want you just to kind of see here, this end of the spectrum is low, that end of the spectrum is high frequency. Now we're also going to talk about energy. This side is low, so now you can kind of see how energy and frequency relate. They're proportional. If one's low, the other's low. That one's going to be high energy. The other part of this is wavelength. This is the symbol for wavelength. We usually measure it in meters. Okay? Or we can also measure it in nanometers. We'll talk about that in a second. Here you'll notice that it's the opposite. This is low frequency, but a long wavelength. And over here, high frequency, high energy, but a short wavelength. Now, our entire electromagnetic spectrum, we've broken up into different parts of the spectrum, and we have names for it. So this lower frequency range is our radio waves. So radio waves are the ones like your AM radio, your FM radio, your cell phone, your TV, all of that is your radio waves. The next section, increasing in frequency or energy, is your microwaves. So this is exactly what you think of, what runs your microwave, heats up your food. Next is infrared. Okay, so infrared, sometimes you might see like infrared goggles that they'll use to be able to see in the dark, those kind of things, if you watch like military movies. The middle one, this is the only one that we can actually see with our visible eye. And so that's why we call it visible light. And this is where we get all of our colors. Okay, and I'll talk about that in more depth in a second. Next is ultraviolet. Okay, so UV light. So you might see this, you might have like a UV ultraviolet bulb or a light bulb. Sometimes they'll use this if we're talking about the sun, tanning beds, that kind of stuff. Next are x-rays. So this is the type of radiation that's used to take an x-ray. And the last are gamma rays. So when you're thinking of gamma rays, you might be thinking of the Hulk or something of that nature. So high energy, high frequency. All right, so the main section that you need to know that we're going to talk about a lot is visible light. So here's the visible light spectrum. And so if we're talking about the wavelength, it's kind of dead center-ish. And we're talking about 750 nanometers down to 400 nanometers. And so this makes our rainbow. If you've ever heard this saying, if you're talking about rainbow, it's Roy G. Biv. Well, this is where we get it. Red for Roy, so red, orange, yellow, G is green, and then Biv is blue, indigo, violet. Roy G. Biv. And this is our color spectrum. Now, you might say, well, what do I need to know about this? Do I have to have any of this memorized? The thing that you really kind of want to know is about visible light. You don't have to know the exact numbers, but I want you to know that for energy, it's kind of in the middle. So you can write that stuff on this slide, what I'm saying right now. So energy, it's kind of in the middle. You don't have to know this exact number, but just know that it's kind of in the middle of the spectrum. Frequency, the same. Frequency, it's in the middle of the spectrum. Wavelength, I want you to know the wavelength. I want you to know that it's 400 to 750 nanometers. So I want you to know the range, and I want you to know that 400 is violet and 700 to 750 is red. So when we say Roy G. Biv, we're going high to low. So the R, our red, is high wavelength to lower 400. So I want you to know this. I want you to know your Roy G. Biv. So 700, 750 to 400 nanometers, not meters. So I want you to know the wavelength, this specifically, and for our energy and our frequency, I want you to just kind of have a roundabout idea of what those are. Okay? And the next lecture, I'm going to explain to you what frequency and wavelength are. How do we actually measure the frequency and the wavelength of light itself?